So I'm moving on with this Beechcraft Baron in X-Plane 11, and I've pretty much got everything set up as I need it now to fly the aircraft around. So what I thought I would do in this video is just take a look at how to use SPAD.next to connect up some of the hardware controls to the functions of the aircraft, and using it as a particular case study, mainly the autopilot and a couple of other miscellaneous functions, just to give you a flavour of how that works, and also how flexible SPAD.next can be. I've got myself a fairly comprehensive panel now using Air Manager. Got all the gauges I need to fly things around, including the avionics. The engine gauges pretty much work. The oil temperatures and pressures still don't really work accurately, but we don't really need those. So we've got all the nav instruments. So we've got the HSI, we've got a nav2 fully functional with glide slope and localizer. We've got a transponder, although we have to set that on the SciTech panel. We've got the comms panel, which is fully functional. Well, I say fully functional, it's a reader. I'm using it as an output only. I've got my comms panel in hardware here. That should be working. We've got an ILS and a VOR set up on the nav radios. So that's nav 2, nav 1. So they're working, and so on. So that panel is pretty much complete. I'm not going to do too much more on that now. I've made one gauge myself, my contribution to this. I've made myself a gauge for the de-icing pressure. When the de-icing boots are active, that's a pneumatic gauge, and that pulses. That's kind of handy to just show that the de-icer boots are operating. That's a one-line piece of code in that gauge, so nothing spectacularly complex. I've had to tweak a few of the gauges from the default Air Manager Beech Baron gauges. I think basically because of the Coronado implementation is different to the default Beech Baron. So I'm hoping to be flying this aircraft around pretty soon, and I'll obviously do some videos connected to that. But what I've been working on most to get it airworthy, if you like, and probably what I'll talk about today in a bit of detail, is getting the autopilot to work. Now, this wasn't as straightforward as I imagined. The autopilot in this aircraft is a Bendix King KFC 225, and I have to say the Coronado one doesn't really work properly. Well, as far as I can tell, and I can tell, I have it on good authority. I've got the KFC 225 manual here. This is the real world manual. And what I don't have is the Beech Baron flight manual supplement, which should accompany that manual for the KFC 225. But I can't imagine there's too many differences in the specific implementation. What can I tell you about that I don't like? There's two dimensions to this, by the way. First of all, there's how the autopilot behaves when you manipulate it from the virtual cockpit just by pressing the buttons. And then there's another dimension added when I wire it up or connect it up to my hardware buttons and switches. Two different sets of issues there. And in the doing of the wiring up to the hardware, you can actually correct or at least modify some of the behaviours. I shouldn't really say correct. I don't know what's going on there. Somebody's driving a baggage truck through me, which is not good. So the main features of this autopilot, which are going to be useful to us, are we've got the standard heading mode, altitude hold, nav mode, approach mode, back course. We've got an altitude alerter with an altitude pre-select, which means we can select an altitude and then we can initiate a climb, and it will intercept that altitude and establish the altitude hold. That's good. We've got vertical speed controls, which on the real thing, you may not see this from here, but I should really bring up a picture of this. So in the real unit, we get control over the vertical speed by pressing the vertical speed button, and then we use the up and down buttons to modify the descent or ascent rate. Now I've modified that in my cockpit to use a rotary control and a push switch, but it's the same deal. I've got the same functionality. So those are the basic features of the autopilot. The one thing that I haven't mentioned is, by default, if none of those modes are selected and you select the autopilot master switch on, the KFC 225 performs an attitude hold function. So it holds the pitch and roll attitude of the aircraft at the point where you turn the master switch on. Now that latter function is the main problem with this autopilot in the Coronado Beach Baron. In fact, it's not that function. The attitude hold works, but there's something else that gets in the way of it being usable. And that is, if you select, I'll try and do this here actually, if you select, oh no, I fixed it. I'll do this with the mouse. If you select altitude hold on, there's no way to deselect that. Now what should happen is, if you press the altitude hold button again, it should deselect the altitude hold, and we should be back into attitude hold, so that's pitch and roll hold. And you probably see, if I do that, what actually happens is, if you press Alt, it momentarily deselects altitude hold mode, but it actually selects the altitude arm mode, and it's armed with the current altitude. And then sooner or later, generally sooner, within a couple of seconds, the autopilot reacquires that target altitude and re-establishes the altitude hold mode. I hope that's clear. Maybe it's not, but basically I think that's a bug in the implementation, or at least it's a glaring omission. I've put in a support ticket to Coronado to try and get a response on that. I imagine they're not going to fix it, honestly. That's a real pain. That gets in the way of using this autopilot properly. So that's one problem. And the reason I'm telling you about these problems in any detail is I'm going to have a look at SPAD.neXt in the remainder of this video, and really have a look at how we can try to fix some of these kinds of issues, as well as how to basically wire up the controls to drive the autopilot and the other controls as well. So the next thing I don't like about the way this autopilot's implemented is that when the master switch is off, as it is now, if you select heading mode, or if you press the buttons for heading, nav, approach, alt or back course, I think any of those, if I choose approach, it selects that mode, or in fact it toggles that mode, but it selects the autopilot master switch on as well. Now I don't like that, because what it means is, if you select autopilot master off and you want to make sure that approach mode is deselected, what you normally do is you toggle it by pressing the switch. That did the right thing actually, that turned it off without turning the autopilot on. That's interesting, that's probably correct behaviour. Altitude mode is on. If I click Alt, well again it's done that faulty arm behaviour, but it hasn't turned the autopilot on. In fact, I haven't quite figured this out, because sometimes it behaves differently. Sometimes it does seem to switch the autopilot on, sometimes it doesn't. I don't know if that's buggy or if I just don't understand what's going on. But the point is, I want to be able to trap that behaviour so that it doesn't happen under any circumstances. So we're going to look at how to do that as well. So here we are in SPAD.neXt, and I don't know how much of this to show you. I might get carried away here. With the home page, profiles, I have a profile set up for the Coronado Beechcraft Baron B58 with the Reality Expansion Pack installed. That's the profile that's currently selected. I've got other ones here, but basically we're going to be looking at this profile. You can do lots of things to manipulate them. You can share them with other people online. I haven't got into that yet. Panels. Well, I do have a radio panel installed, so this will show me, if I manipulate it, you can see the buttons and knobs moving. But we're not going to look at this for now either. This is the page that we're really most interested in. If you look at the left hand side here, you can see all the devices I have connected that are recognized by SPAD.next. Most of these are Leo Bodner BBI32 boards, which are distinguished only by their serial numbers here. You'll see I've got another few things at the bottom here. I've got the VirtualFly Yoko, which is the one that's currently selected. I've got two Cytec quadrants, crosswind rudder pedals, and so on. I've got the Yoko selected. If I press the button on the Yoko, I'm pressing the left hand and the right hand push switches there. That's the left-right paddle switch. So if you press the button on the controller that's selected, you get an indication about which button it is. That's button 8, that's the right hand push switch. Let's click on a button that's not mapped. Button 7, I don't think that's mapped to anything. If I click on that button, nothing appears down here, so there's no functions mapped to that button at the moment. If I go add event, you'll notice that the kind of events that you can bind actions to, they're quite varied, but it's not immediately obvious what these things are. In fact, this is a little bit confusing. What I generally just want is this to act like a normal push button. So I want to be able to map one event to the button press, that's the down operation, and another event to the release or the up operation. It's not immediately obvious how to do this. And incidentally, one of the reasons that SPAD.next is not only useful, but is actually essential, or something that can do the same thing is essential for X-Plane. X-Plane, God only knows why, has no facility to map functions to the button release operation. Anyway, with SPAD.next, what I suggest you do, and this should be default I think, is to change the behavior of the button by before going to add any events to it, select the button, go to Configure Button, and you can choose normal push button is all the events we've just seen. If you choose simple push button and go to add event, now we only have button pressed or button released. So if we go button pressed, then we can select an operation. Let's say we want that to be rudder trim right and left, because that's the left right paddle I was operating on the Yoko yoke. If we go add action, we can choose lots of different kinds of actions. The two things that are most of interest generally are simulation event and change data value. Pretty much those two options are the same as what you can select in FSX with something like FSU IPC or Linda. So let's do a simulation event, and we'll see if we can find one that's about rudder trim. So if I type in rudder, you can filter this list. Rudder center, left, right. So we go rudder right. That's probably going to do what we need. So if we go OK, and then OK, and then OK, and then if we choose the other button, which is the paddle left, we want to do all the same things. So we want to select it, configure it to be simple push button. OK. We're going to add an event. It's button pressed. Add an action, simulation event, and the list is at the same position we left it. We're going to go rudder left, and we're going to go OK, OK, OK. Then we click this red button here, which is a save. Save. I'm not going to save them because I don't actually want those. So that's just a simple way to bind something to a control. If I just, in fact, go back into this, so this is rudder. In fact, that probably isn't rudder trim at all. That's probably rudder, move the rudder to the left. So we want to go in there and say, look, actually we've got that wrong. If I delete that action, let's add an action, and we'll go change data value, and we'll type in rudder. So this is looking at the list of known data refs, which are variables within inside X-Plane that are all readable. Many of them are writable as well. So rudder trim time, rudder tab, rudder trim, minimum rudder trim. None of these really looks like rudder trim. There's one, rudder trim, percent over 100. So we can actually change the value here. So 0.3 is 30%, 1.0 is 100%. If we were to set this up as an action to modify the rudder trim, when that paddle is moved to the left. We'd select rudder trim. The operation would be, we don't want to set it to a particular, we could somehow calculate the value, but we have an option to increment or decrement, so we could decrement that value. We know that the spread of this is 1.0 and we can modify that in, well, it will tell us on here actually, we can modify that in, I think that is increments of 0.0001, which we're not going to worry about that too much. But let's say we would decrement the rudder trim by 0.1. That's a tenth of the maximum rudder trim. So there we go, we'd save that, and hopefully that would operate our rudder trim. So that's the basic way to map an event or a modification of a data ref to a button or a switch. Let's have a look at another facility which is very useful. Again, you can't do this in X-Plane natively, and we'll look at manipulating the heading bug. Now my heading bug is on a rotary control. We've got left, right and a push switch. If I was using Linda, if I just pushed the button or rotated the knob, it would flip automatically to select the appropriate device. That doesn't actually happen in SPAD.next, so you actually have to go through and select each one in turn and then fiddle with the control to see if it moves. I'm having to do this laboriously. It's going to be the last one we try, isn't it? It's always the way. There it is, and the push switch is actually on a different, but we'll come to the push switch in a minute. But the left and right are buttons 11 and 12 on this particular BBI32 board. But for now, the heading bug is on, and this is already programmed, so I'll just show you buttons 11 and 12. So moving it to the right is button 12. If I click on button 12, we've got button pressed, increment heading magnetic by 10. I'm presuming the whole range of this is 360. In fact, this is slightly confusing because we've got two actions here. One says when the button's pressed, we'll increment the heading magnetic heading by 10. The other one says when the button's pressed, we'll increment the magnetic heading by 1. But you'll notice the word conditional in there as well. If I go into the first one in the list and go edit event, we've got at the bottom box here, we have this action to increment. So this is a data ref value. If I were to go in, select that and edit the action, we've got the data ref selected is the magnetic heading, and the option is to increment that by the value of 10. Interestingly enough, another feature that we've used here is we have the ability to limit that, or to put constraints on the value that can be set in that data ref. So we select the limits from off to on, and the type of limit, we can put a minimum and we can put a maximum, but we can also very usefully for a dial type of control, such as the heading bug selection on the HSI, we can roll over. So when it gets to 359, it'll roll over to 0. It's exactly what we wanted to do, so that's all set up. The other thing to notice is we have a condition set up here. Now then, this is interesting. We have a condition that checks the value of something, and if that value is set to 1, and it's called rotary shift, that value is called rotary shift. If that is set to 1, this action is carried out. If that condition is not met, this action is not carried out. This is a little bit cumbersome and a little bit fiddly to understand, but if we go into the other one in the list, edit that event, everything's the same except the increment is by 1 degree, this is, and we check the same variable, rotary shift. If it's equal to 0, we execute this event. So what happens is when you press this button, in fact both of these actions are considered, and if you think of it as like a little algorithm, it runs the algorithm for the first conditional action and then it runs it for the second conditional action. There's more finessing to be talked about here. I'll just briefly show you that. If you go back into this first action in the list, if it actually carries out this action, executes this increment action. We have an option here to end processing, and that says yes. And what that means is if it actually executes that action, subsequent ones in the list, we could have 10 or 20 actions in this list if you like. It basically aborts the list of actions if that one is executed. I hope that makes sense. The reason that's hard to explain is it's actually quite a cumbersome, inelegant and in some ways unsophisticated way to implement this. What we really want here is to be able to run a script and to write that as a piece of program code. If you were using Lynda under FSX, you would literally be able to do that by writing a Lua script, and the logic would be much easier to lay out. As far as I know, in SPAD.next, now I may get this wrong, so don't take this verbatim. As far as I know, there is no facility to code your button operations as Lua scripts. Now I'm not sure about that because somewhere elsewhere in this user interface the word script does appear. Script panel we have here. I don't really know what that's about. And the other thing that makes me think that it's possible that somewhere undiscovered Lua, this product does actually make use of Lua in various places. Well, anyway, we'll get to that later. But for now, this is how you have to program conditional operations. The other part of this is, what's the thing that gets checked in this condition here? If I edit the condition, the source it's actually a local variable. We've got variables that we can check within X-Plane, which are all the X-Plane data refs. If you're familiar with X-Plane programming, you'll kind of know some of this stuff already. But we've also got local variables. And some of these, I don't know where these come from, but these are presumably filled in somehow from the particular devices that I have connected. But you can define your own persistent local variables. And indeed I have done that. That's what the variable rotary shift is. It's a number, and basically it can hold a value, and if you put a value in there, it stays there till you look at it. And you can set the value within one button press event, and you can check it in another button press event, which is very convenient. It's exactly what we want to do. And so what I'm doing here is I'm setting that variable on in the event handler for the central push switch of my rotary control. Now I have to find that in the same laborious way. There it is, button 26 on this BBR32 board. If we look at that, configure button again shows me it's a simple push button, so it's got an up and down event. On the button press we set the local rotary shift variable to 1. On the button release we set the local rotary shift variable to 0. What this means is you can press the button and hold it pressed, if you like, pushed, the rotary control, turn it to the right, and in the event handler for the right button click, the rotary shift variable will be read as 1, which means that we can interpret that as wanting to increment the heading or decrement the heading by 10 degrees. If we rotate that rotary control without holding the center button down, in other words unshifted, when we check that value of rotary shift in the event handler for the left or right button push, we find it to be 0, so we increment by 1 degree or decrement by 1 degree. That's a very, very long-winded way of describing this, and I hope you followed the explanation, but it's an extraordinarily useful feature, that ability to set a variable and then check it from elsewhere. And in fact you'll find that use of rotary shift on my panel. I've used that in setting the ADF heading, the nav1 OBS, the heading bug on the HSI, the nav2 OBS, setting the altitude alert, which we'll see when we look at the autopilot. I've used it again to pre-select the altitude in units of 100 feet or I think 1,000 feet or maybe 500 feet. So there you go, very useful function. So let's have a look at the autopilot. A couple of things to say about the autopilot. The autopilot engage and disengage switch is button 23 on the BBR32 I have selected now, and you'll notice, if you can hear the sound of the click, I'm not holding that button down. That's actually a toggle switch. And if I were to click on that button and go to Configure button again, you'll see that this is not. I could just have selected this as a simple push button, but we also have the option of selecting this as an on-off switch, which I have done. That's just a nuance that, I'm not going to go into all the nuances of this because we'll be here not just all day, we'll be here all week. But there are subtle differences, and there are many more features about how you set these buttons up. But here on the event window down here, you can see that we've got a switched on action and a switched off action. If we look at the switched on action, we'll go to Edit Event. It's an unconditional action, and we change the data ref, which is setting the autopilot mode to 2. Now I happen to know through the process of research, in fact let's look, this, if we go to Edit Action, autopilot mode, in this list it usually gives you somewhat helpful information about the data ref. So autopilot mode, it says it's a number, and it's actually got some usage notes here. You don't always get this, but this tells me what I need to know, which is the autopilot master mode, basically off, and in this aircraft off 0 and on 2 are the significant values. In other aircraft, notably if you watched a previous video about the RW Designs Twin Otter, the flight director mode is actually significant in that aircraft as well. I mean, the flight director notionally can be on while the autopilot is switched off. In the Coronado Beechcraft Baron, that distinction is not really modelled, or if it is modelled, it's not modelled correctly in my view. So anyway, for now, what we've done is, when that switch goes on, the autopilot mode is set to 2. When the switch goes off, we do something slightly more involved. We set the autopilot mode to 1. I'm not sure why I've done that actually. I wonder if that's the source of some of my problems. I've got a feeling I should set that to 0 when I flip that button off. Anyway, for now, I've changed that data ref to set the flight director mode of the autopilot, which basically disconnects the autopilot servos. Probably is supposed to leave the flight director active. And I've also set the flight director mode to 0. Let's see if we get some hints on what that means. Flight director mode 0 is off, 1 is on, 2 is on with servos. It looks like when I set this up, I hadn't decided whether I should be manipulating the autopilot mode or the flight director mode to control the autopilot master switch. So that's a loose end I need to tie up. But anyway, for now the autopilot master switch does respond to on and off more or less correctly. So we'll leave that alone for now. The next thing I want to do is look at just programming one of the mode buttons. So if we look at the heading mode, hopefully we're on the same BBR32 board. It's button 26, so if I select that, again, that is a simple push button. We do something on the down event. It is conditional, and I'll tell you why it's conditional in a second. We don't manipulate a data ref here. We actually just send an event, which is the, if we go into edit this again and look at the list of events, we should see if I filter this by autopilot, and we go for, what was this again? Heading. Heading is the autopilot heading hold. It says in the usage notes down here. We should find nav, which gives us the nav mode, which tracks to a VOR or to a localizer. We've got the, what else have we got? We should have an approach mode. So there you go. Basically we just select the appropriate command. These are default X-plane commands, which it appears that the Coronado Baron responds to, and we send that. Now if you listen to what I was saying earlier about the drawbacks of this autopilot, which make it a little bit less usable, sometimes for some reason, under some circumstances that I haven't quite figured out, when the autopilot master switch is off, if you press one of these buttons to select the mode, it turns the autopilot master switch on, and that gets in the way because it's just unexpected behavior. Now it may be that this is down to that wrinkle that we saw when we looked at how I've coded the autopilot master switch. But for now, as an example, you can see how I've fixed it. Basically, I'm doing this as a conditional operation. I will only respond to that button if the autopilot is actually selected on. If the autopilot is off, this button event is ignored. And indeed, if we look at what I've done for nav, that's button 24. Same deal. If the autopilot mode equals 2, we send the event, otherwise we don't do anything. Approach mode. Same deal, autopilot mode equals 2, we send the approach event. So that's how to program your buttons using conditional events in a way that allows you to modify the default behavior if you want. Okay, let's look at another control on the autopilot. I've mapped the altitude pre-select function to a rotary control. That's buttons 17 and 18 for the left and right events on this BBI32, and button 22 for the push switch. If we look at the push switch first, again you'll see I've used that manipulation of the rotary shift local variable, setting it to 1 or 0. That allows me to do a different action on the left and right events of that rotary knob. So if we look at the turning it clockwise event, we've got 2 conditional events. Well, now then, this allows me to show you another feature here. Only the top one says conditional, but if you remember this facility whereby if we set the end processing flag to yes, that means that when this list is, if you imagine this list is executed top to bottom, as soon as one of the conditions is executed and has the end processing flag set, the processing of this list of events is terminated. So it's like a go to end or an exit function, if you like, if you're familiar with programming idioms. Now the problem with that is we have to make sure that this list is in the appropriate order. The way you set the order, it would be nice if you just could scoot things up and down this list by saying move up, move down, but actually you don't seem to be able to do that. You have to set the priority. You can see here we've got a priority 0 and 1. If I go back into there, you can set the priority here. You can set that to a number. The higher the number, the higher the priority. So, that's, in one sense, that's a sophisticated function because it allows another layer of complexity. In another sense, it's a dreadfully inelegant way to change the order of execution. That's reminiscent, in my book, of lines in, if you're familiar with FSU IPC, if you want to do conditional or multiple button actions, you have to edit the config file, and the config file has to have sequentially numbered lines. It's a bit like that. But we're not going to bitch about it too much. It lets us do what we want, and it means that that second button event doesn't actually need to be conditional. Technically it is conditional, but it's this condition that's determining whether or not this gets executed. So back to the plot. The most high priority one is the event that says if local variable rotary shift has a 1 in it, which means the knob is being pushed in whilst it's rotated, this should say increment the value of the data ref altitude by 500 feet. Now it doesn't say that. If we wanted it to say that, let's just say we'll go add action, change data value, we'll look for altitude. There is a variable called altitude, which is altitude dialed into the autopilot. We could select that, and we could say increment by 500. That setting is in feet. Incidentally, this just as a matter of interest, this shows you that you can have multiple actions. You can have as many actions as you want executed together for any given button event. Now I'm going to delete that again. We haven't done that. We've got something else here, which is we set altitude instead to the value of another local variable, apparently another local thing called altitude up 500. Now that's not actually a variable. If I find where that is, I'll show you another powerful yet highly idiosyncratic and fiddly feature. If we go to a tab in the user interface or a screen in the user interface, which for reasons unknown is called add-ons, we find a number of things. First of all, we find something that looks great but doesn't actually work, which is data monitor. We can add one of those Xplane data refs in here, and whilst Xplane is running, notionally rather, the value of that is displayed. Now that doesn't actually work. It's not implemented for Xplane yet, apparently. You'll see clues down here that we've got SimConnect variables, LVARs. This should clue you in that this program also can work with Flight Sim 10 or P3D. We could look at the value of LVARs and SimConnect variables. That is implemented, and I'm presuming that in future iterations of this product the data monitor will work with Xplane. But anyway, we're not interested in those. The one we're interested in at the moment, there's another one that says scripts. Again, I keep seeing the word script around here. I'm wondering if there's a way to do Lua scripts, but we'll find that out presently. But the one I'm interested in is called expressions. Now this is a horrible looking screen, not very well designed, but you can add an expression. You can give it a name. Let's say altitude, I don't know, we'll just for some reason plus 10. I don't know why we'd want to do that. And then we can go add data, and we can select Xplane data ref, and we can do arithmetic on it. And if we were to, actually if I validate this, is not going to work. Oh, it is working. I'm saying that because Xplane's not running at the minute, but on the assumption that Xplane was returning 400 feet, the value of this expression, which is accessed as if it were a local variable called altitude plus 10, returns 400 plus 10, 410. Now that's not a very useful thing to do, but if you look at a couple of the variables I've defined, we've got altitude up 500. If I edit that expression, you'll see that, in fact you'll see two interesting things here. One is a little bit of tweaking here. That's basically an algorithm to round the selected altitude to an increment of 500 feet. Now the reason for that is when you press the altitude hold button on the autopilot, it will literally hold the current altitude, which is almost always going to be a very untidy altitude, like 4,203 feet or something like that. That will then be selected on the autopilot, and if you were to just, when moving the altitude pre-select, increment by 500 or by 100, you're going to get 4,203, 4,703, 5,203 and so on, and that's not what you want. What you want is, when you manipulate that altitude pre-select, you want it to round, if we have it shifted, to the nearest 500 up or down, and if we have it unshifted, to the nearest 100, which is why there's also another custom variable called altitude up 100, and then the equivalent altitude down 100 and altitude down 500. Now before I get rid of this, the one other interesting thing to point out is we've used a function. This is a Lua function called floor. This is something that truncates the, I forget exactly what this does, floor truncates to the integer part, but the point is it's a Lua function, and that is a clue that underneath the hood SPAD.next has a Lua engine built in, which is good news, but it does mean you can use various arithmetic, possibly bit manipulation functions and so on in expressions such as this. So anyway, we define that here, give it an identifier, and as we saw back at the controls, it's accessible in the same way as those local variables. So if I were to edit the action and go, again, this is another thing we haven't looked at yet. What the data ref we're setting is altitude. What we're setting it to, normally that would be a specific value, and we'd put a value in there, a terminal value you might call that if you're a programmer. In this case we're setting it to the value of, can be the value of another data ref, or it can be the value of a local variable or a local expression. So we've selected one of those custom expressions. Just as we pass through here, you'll see I've created another couple of, or a whole bunch actually of local expressions. I don't think I'm using these at the minute, but these were during my experiments. I've created these to look at particular bits in the altitude status. The altitude state, if we can we edit this from here? No, let's go back to the add-ons, expressions menu. If we go to is altitude hold on variable and we edit that, we're looking at a data ref called sim cockpit autopilot state. Now I happen to know that's a bit map. It's a 64-bit bitmap, or an array of 1-bit flags you might call that, and I happen to know that bit 14 or 15, depending on whether you number them from 0, is the altitude hold flag. And if you're a computer nerd, you will know that 2 to the power of 14 is 16,384. That's the decimal value, and we're checking to see if that's 0. If that's not 0, altitude hold is on, so that returns a Boolean value. Another one is that bit checks to see whether the altitude arm flag is set. So that's an explain specific thing which you may or may not care about, honestly, but I thought I'd point that out as we go. So that's pretty much all I'm going to show you about SPAD.next and how I've used it to repair some of the faulty or otherwise deficient behaviour of the autopilot in this aircraft. There's tons more I could show you about this. The main problem with SPAD.next at the moment is there's no manual. There's a manual that comes with it, and it's about 50 pages, but it's just a quick start manual, really, honestly. And a lot of these functions that I've showed you are not discoverable strictly, and the only way I've discovered them is to go to the support forum, ask a stupid question, and then someone's pointed me at, oh, well, you can do this, didn't you know? And lo and behold, there's a way to do it. So, SPAD.next, again, if you look at the version number, it's 0.9.5.81. It's in essence a pre-release. What's the term these days? Early access. So people are paying for this. There isn't a manual. It's not fully functional. But that said, it's a godsend at the minute, certainly with X-Plane. But what else can I tell you about this just in passing? If you go to the settings page, there's a number of things you can look at, but the interesting one is application. And under application we can look at different simulations or simulation protocols, if you like, that are supported. You see I have selected X-Plane support. For some reason I've got Euro American Truck Simulator supported. Don't think we need that one. Some changes will become active. Okay. iRacing, I don't know what that is. I've got that support switched on as well. Now some of these are not available. LVAR support, SimConnect support, those things are not actually available because this is a per product purchase. If I want to purchase SPAD.next functionality for Prepared or for Flight Sim 10, I have to make that as a separate purchase. There is a thing here called the Complete Edition, which gives you all of that stuff for one price. What does buy add-ons do? Oh, here we go. Here's the pricing. There's one more thing I'll show you. Mostly we've looked at programming BBI32 Leo Bodner boards here, but I've got one Leo Bodner BU0836X interface. Now if you're familiar with the Bodner boards, you know that's got analog axes on as well. And if I twiddle my rudder trim axis, you'll see that this program understands analog controls as well. If I go to the Virtual Fly Yoko, for example, manipulate the yoke, you'll see that I could map my analog axes from here as well. If I look at the the elevator axis, if I click on that and go, well, there's a calibrate, which I'm not going to do anything with. Add event, and I can choose a standard axis, which shows me all the standard X-Plane axes available, and so on. I'm not going to do this because I have my analog axes all set up using the native X-Plane dialog. And now the reason for that is, I think, well, again, I'm going out on a limb here, I don't think the analog binding works 100% in SPAD.next. I did start off trying to do some of that. I've got a feeling maybe my rudder pedals are actually bound through SPAD.next. No, I'm wrong about that. I did start off experimenting with that, and for some reason I had problems. So I've gone back and mapped all my analog axes in X-Plane. But again, this is something that's being developed actively. I think one of the things that's being considered is the option of having tailorable envelopes for or response curves, if you like, for the deflection of the analog axes, as you can do in a limited way in FSU IPC. That would be an excellent addition. So that's something to watch out for. But this program, despite its clunkiness in some ways, is definitely going places as a product, and I'd certainly recommend it, particularly, as I said, if you're using X-Plane and you're stuck with the standard way of mapping buttons and switches, which is frankly deficient, we'll say.